Hi, this is the pre-lab video for the copper remediation lab. Let's go through some of the pre-lab questions that you're going to answer first. In this unit, we're looking at how we dispose of oftentimes toxic waste. And as you can read in the background information of the lab, there's a lot of copper waste solution that's created from a number of different industrial processes, including copper electroplating. So the purpose of this lab is to see if we can remediate that copper and get it down to a safe level so that it's not toxic and it can be properly disposed of. The equipment that you'll be using in this lab is the Vernier LabQuest with the colorimeter. You used a turbidity sensor in water testing that worked in a somewhat similar way to the colorimeter. So the instructions tell you which wavelength to set your colorimeter at. And it also instructs you to perform a calibration, which is very simple. This is just a one-step calibration. So when you put your distilled water in and hit the calibrate button, you should get an absorbance reading of 0. So the way the colorimeter works, as you can see from this diagram, is that I'm going to put a little cuvette in here, and it's important that the cuvette is positioned. There are ribbed sides and clear sides, and I want that light source to be able to travel through the clear sides. So I always hold it by the side with the ribbing or edging on it and wipe off those clear sides with a tissue or paper so that the light can pass through there very easily without being impeded at all. So the colorimeter is measuring the absorbance of that solution, and you can see that our original 50,000 ppm or part per million solution is very dark in color. And so there's going to be a relationship between how dark or how concentrated that solution is and its absorbance. The other part of the pre-lab is dealing with the second portion of the lab, in which we're going to take an unknown copper chloride solution and see if we can get some of that copper out of there. That copper is a valuable product that I want to recover, so I'm going to do a simple single replacement reaction and put aluminum metal in with my copper chloride solution. That copper is precipitated out, and I am left with a solution of aluminum chloride. Remember that that equation is not yet balanced, so you'll have to do that in your pre-lab. In terms of lab management, working in your big lab groups of 4, 2 people will start part 1 of the lab, and 2 people will do the second part of the lab. So let's go through what those individual parts look like. In the first part of the lab, you'll be performing a dilution and testing that diluted concentration in the colorimeter. So you notice that you start with 10 milliliters of the original 50,000 ppm solution. You're going to take 5 milliliters of that and add 5 milliliters of water, and you will end up with a 25,000 part per million solution. You're going to continue that. I'm going to take 5 milliliters of the previous concentration, take 5 milliliters of that and add 5 milliliters of water. You always want to make sure that you mix your new test tube of solution really thoroughly before you drag 5 milliliters of that to the next test tube and dilute it down. Notice that your data table also has a spot for you to record which unknown number you're assigned and the concentration and absorbance of that. After you do step 2 of the lab with your unknown and you pull out that copper by reacting it with aluminum, you're going to take the filtrate from that solution, which is your remediated copper solution. So you're actually going to be testing this new aluminum chloride solution that formed to determine if you indeed were able to get all of the copper out of that. The second half of the lab, this is what your different solutions are going to look like. So when I put them into the colorimeter, the clearer the solution, the less absorbance. That light is going to pass right through there. When I have a very dark solution, that light is absorbed by the particles in the solution, and I end up with a lower absorbance reading. So to set up the LabQuest for the first part of the lab, we're doing an events with entry. This is all clearly spelled out in your pre-lab, meaning that I'm not collecting data and then just stopping. I'm not collecting data over time, which is a traditional method that we use. We have 7 different test tubes that we want to determine the absorbance of based on the concentration. So my event that I'm doing is concentration. The colorimeter can measure the absorbance of this dark solution, how much light is absorbed or passes through it, but it has no idea what concentration I have. So when I look back at my original data table, if I put this first test tube in there, I take the test tube full of solution, dump just enough of it in to get the cuvette 3/4 of the way full, I know the concentration of it. So when it gives me a stable absorbance reading, I go ahead and enter that corresponding concentration. So the minute I hit start for my data collection, this keep button will appear. I don't stop data collection in between my trials. When I put a solution, a certain dilution into the colorimeter and the absorbance reading stabilizes, I simply hit keep, which means it's going to lock in that absorbance value, and a little dialog box will pop up where I can then tell it what that corresponding concentration was. The second half of the lab group will start part 2. And the directions for this are pretty straightforward. It's the reaction that we went over in the pre-lab. And you're going to add those ingredients to the Erlenmeyer flask, those reactants to the Erlenmeyer, and swirl it around and let it react for 5 to 10 minutes. While it's reacting, you can go ahead and mass a piece of filter paper, fold it according to the directions, pour your filtrate through there to capture all of the precipitated copper in the filter paper, and then remember you're going to take that filtrate to the first team once they've got their standard curve on there, and go ahead and determine the copper concentration of that to see if we were able to get all the copper out of there. Let's kind of wrap up our pre-lab video by looking at this idea of a standard curve. So the colorimeter, as we mentioned, is going to be measuring the absorbance, which is my dependent variable, and the absorbance is dependent on the concentration of the solution in parts per million. Once I get all of my data points locked in, I'm going to put a linear fit or best fit line on there, and I will then, once I've got that relationship between concentration and absorbance, I'm going to put my unknown into the colorimeter, and I'm going to read the absorbance of my unknown solution. I want to determine what its concentration is, and I'm going to use my best fit line to do that. So if I do analyze, interpolate, that's what these values are showing me down here, I can go at any point along this line. So let's say, for example, that I have an absorbance reading of approximately 0.933. It's telling me that my solution concentration is 19,900 parts per million. So that's how I'm going to get my unknown concentration originally, and then that aluminum chloride filtrate, after I've reacted it to get all the copper out, I want to test the concentration of that as well to see if indeed I did get all the copper out. Good luck. See you in lab.